Now let's take the next topic, which is symmetry. What is symmetry? If a figure is divided into two identical parts by a line, then the figure is symmetrical about that line, and that line is called the line of symmetry, or also called the axis of symmetry. A figure can have no lines of symmetry, or it can also have many lines of symmetry. Now, why should we draw lines of symmetry? By drawing lines of symmetry, we can know how many ways can we divide a figure into equal parts. Now, how to find the lines of symmetry for different geometrical figures? Let's start with a line. Now, a line has infinite lines of symmetry. That is, all the lines which are perpendicular to the given line are its lines of symmetry. Now, if we have an angle, there is one line of symmetry, that is the angular bisector. Now, for a segment, there are two lines of symmetry. One is the perpendicular bisector and the other one is the segment itself. Now we have an isosceles triangle that will have one line of symmetry, which is the angular bisector of the vertex angle, which will also be the perpendicular bisector of the base. Now for an equilateral triangle, there are three lines of symmetry. They are the angular bisectors of the three angles. Next we have is an isosceles trapezium. We have one line of symmetry, that is the perpendicular bisector of the parallel sides. Next, if you have a kite, its line of symmetry will be one of its diagonal. And same way for an arrowhead, one line of symmetry, that is one diagonal. Now for a rhombus, there are two lines of symmetry, which are the two diagonals of the rhombus. For a rectangle, there are again two lines of symmetry, which are the perpendicular bisectors of the opposite sides. Now for a square, there are four lines of symmetry. The two lines of symmetry will be the perpendicular bisectors of the opposite sides and also the two diagonals. So we have four lines of symmetry for a square. Now for a circle, there are infinite lines of symmetry. All the lines which are passing through the center will be the line of symmetry. Now if we have a semicircle, then there is only one line of symmetry. Now if you have a regular pentagon, pentagon means a five-sided figure, there will be five lines of symmetry, which are the perpendiculars drawn from the opposite sides. Now for a regular hexagon, hexagon means six-sided figure, there will be six lines of symmetry, which are the lines joining the midpoints of the opposite sides and also the diagonals passing through the center. Now regular octagon, octagon is a eight-sided figure, so there will be eight lines of symmetry, that is the line joining the midpoints of the opposite sides and also the diagonals passing through the center. So there are four such lines, the perpendicular lines and four diagonals, so there will be eight lines of symmetry. I hope you've understood this well. Now, the prerequisites for this topic are, you need to know how to draw the angular bisector, then the perpendicular bisector, also to draw a triangle and a quadrilateral with the given measurements. Now let's take some problems based on this topic. We take the first problem, which is, Using ruler and compass only, construct a regular hexagon of side 3 cm. Draw all its lines of symmetry. Now in this sum, we are asked to draw a hexagon of side 3 cm. Now we first draw a circle of radius 3 cm. Then we mark a point A and then take AB as 3 cm, 2 points on the circle. Now from the point B, cut an arc of 3 cm. Then again from that new point, say C, cut an arc of 3 cm and so on. We join AB, BC, CD and so on. We get the hexagon ABCDEF. Now we want to draw its lines of symmetry. We know that for a hexagon, the lines of symmetry are the perpendicular bisectors of the opposite sides and also its diagonals. So we join the diagonals AD, BE and CF. They are the 3 lines of symmetry. Now also draw the perpendicular bisectors of the opposite parallel sides. We will again have the 3 lines of symmetry. So a regular hexagon will have 6 lines of symmetry. Now let's look at our next problem. Use ruler and compass only. Construct the quadrilateral ABCD such that AB is 5 cm, BC is 7 cm and angle ABC is 120 degrees. Given that AC is its line of symmetry. Write down the geometrical name of the figure ABCD and also measure and record the length of BD. Now in this figure, in the first part, we are asked to draw the quadrilateral ABCD. To do that, we will first draw the triangle with the given measurements AB as 5 cm, BC 7 cm and angle ABC as 120 degrees. Once we draw this, as shown on the screen, now we want AC to be its line of symmetry. So we take a point D such that perpendicular distance BN is equal to ND. I repeat, we take the point D in such a way that the perpendicular distance BN is equal to ND. Now join AD and DC to complete the quadrilateral. So ABCD is the required quadrilateral. Now in the second part, we want to write down the geometrical name of the figure ABCD. Now in this figure, we see that AB is equal to AD and BC is equal to CD. That is, the adjacent sides are equal. But here, the diagonals are not equal. So this figure is a kite or a diamond. Now we are asked to record the length of BD. From the figure we have BD is equal to 5.8 centimeter. Now let's consider the next problem. Here we have draw triangle ABC having A minus 1, 0, B 3, 0 and C minus 1, 4. Draw the line of symmetry of triangle ABC. Find the coordinates of the point D if line N1 and BC are both lines of symmetry of the quadrilateral. Assign special name to the quadrilateral ABCD. Now to solve this, we will first mark the points A, B and C as we are given their coordinates. Now join A, B and C to obtain the triangle ABC. Now if we look at this figure, we have AB is equal to AC, which is 4 centimeter. AB is 4, AC is 4. So we have an isosceles triangle. Now the line of symmetry will be L1, that is the angular bisector of the vertex angle, which is also the perpendicular bisector of the base, that is BC. We draw this at point M. So we have drawn the line of symmetry of triangle ABC. Now for the second part, we want to find the coordinates of the point D. Now if BC and this line L1 have to be the lines of symmetry, then we take the point D on the opposite side of point A such that distance AM is equal to distance MD. So we get point D as 3, 4. Now for the third part, we want to assign a special name to the quadrilateral ABCD. From the figure we have all the sides of this quadrilateral are 4 centimeter each, and also AD and BC are its two lines of symmetry. So this figure has to be a square. Now in the fourth part, we are asked to write down the equation of AD. You remember we are done how to find the equation of a line. We are given the two coordinates A and D. A has coordinates -1, 0 and D has coordinates 3, 4. We want to form the equation of the line. So we first find its slope as y2 minus y1 upon x2 minus x1, that is 4 minus 0 upon 3 minus of minus 1, which is equal to 4 upon 3 plus 1, that is 4 upon 4, which is nothing but 1. Now the equation of the line will be obtained by y minus y1 is equal to m into x minus x1. We substitute the values, we get y minus 0 is equal to 1 into x minus of minus 1. That is y is equal to x plus 1. So we write the equation as x minus y plus 1 is equal to 0. Now for the next problem, we are given use graph paper for this question. Plot the points A 8, 2 and B 6, 4. These 2 points are the vertices of a figure which is symmetrical about x is equal to 6 and also y is equal to 2. Complete the figure on the graph. Write down the geometrical name of this figure. Now let's use the graph paper for this. We first draw the number line. On the x-axis, we can mark points up to 10, and same way on the y-axis, we mark points up to 10. Now on this, we plot the points A 8, 2 and B 6, 4. Now we are given this figure is symmetrical about x is equal to 6. So we first draw the line x is equal to 6. Now x is equal to 6 will be a line which is parallel to the y-axis at a distance of 6 units from it. So we draw that line. Now we want to mark the point A dash. A dash will be 4, 2. This is because distance of point A from the line x is equal to 6 is 2 units. So the distance of point A dash from the line x is equal to 6 should also be 2 units, but on the opposite side of A. We'll get the coordinates of point A dash as 4, 2. Now in this figure, it is also symmetrical about the line y is equal to 2. So the same way, we will get the point B dash as 6, 0. Now we join A, B, A dash, B dash. Now in this figure, we see that all the four sides are equal to each other and also the diagonals are equal. So this figure is a square. Now we take the next problem. It says, use graph paper for this question. Use 2 centimeter is equal to 1 unit on both the axes. It means here we are given the scale for the graph. We have to take 2 centimeter as 1 unit on both the axes. Now plot the points A, -2, 4, B, 2, 1 and C, -6, 1. Draw the lines of symmetry of triangle ABC. Mark the point D if the line in 1 and the line BC are both the lines of symmetry of the quadrilateral ABCD. Also write down the coordinates of the point D. What kind of quadrilateral is ABCD? We also need to write down the equation of BC and the line of symmetry named in part 1. Now we take the graph sheet and we draw the x-axis and the y-axis. We take the scale 2 centimeter as 1 unit. Now we will mark the required points. On the x-axis we can take from -7 up to 3, and on the y-axis we can have from 5 up to -3. We can also draw extra points. There is no harm in that. Now we plot the points A, B and C. Now join ABC to get the triangle ABC. Now we observe from the figure that ABC is an isosceles triangle. Now in the first part of the question, we are asked to find the line of symmetry of triangle ABC. Since we have an isosceles triangle, its line of symmetry will be the angular bisector of angle A, which is also the perpendicular bisector of BC. So we draw that line, that is the required line of symmetry. Now, in the second part, we want to mark the point D such that the line in 1 and the line BC are both the lines of symmetry. Now mark point D on the opposite side of A such that AM is equal to MD. We will get D with coordinates -2, -2. So we have got the coordinates of point D. Now for the third part, what kind of quadrilateral is ABCD? Now in this quadrilateral, all sides are equal and the diagonals bisect each other at 90 degrees, but the diagonals are not equal. So this figure is a rhombus. Now in the fourth part, we want to write down the equation of BC and also of the line of symmetry obtained in 1, that is the line AD. Now line BC is a line parallel to the x-axis and at a distance of 1 unit from it. So the equation of line BC is y is equal to 1. Now same way we can get the equation of line AD. This line AD is a line parallel to the y-axis at a distance of 2 units from it but on the negative side. So equation of line AD is x is equal to -2. Now let's look at the next problem. Here we have part of geometrical figure is given in each of the diagram below. Complete the figure so that the line M in each case is a line of symmetry of the completed figure. Also give the geometrical name of the completed figure. Recognizable freehand sketches would be awarded full marks. Now let's take the first one in this. We are given a triangle PQR and line M is the line of symmetry. So we draw the same on the other side of the line M. We get triangle P, Q dash and R. Now we've drawn the figure in which M is the line of symmetry. What is this figure? This figure is a kite and it has one line of symmetry. Now let's take the second part in this. We are given a triangle ABC with AB as 3 cm and BC again as 3 cm. Now we draw triangle AB-C with AB dash as 3 and B dash C as again 3 cm. So we've got the required figure with line M as the line of symmetry. Now this figure is a rhombus because all the four sides are equal and we have this diagonal. We draw the second diagonal. We will see that they meet at 90 degrees. So all four sides are equal and the diagonals bisect each other at right angles. So the figure is a rhombus. Now let's take the third one. We have a triangle XYP. Now we complete this figure. Draw the same thing on the other side. Now this figure will be an isosceles triangle with line of symmetry as line M, which is the angular bisector or the perpendicular bisector of the side. We take the fourth one. In this, we have a quadrilateral ABCD with dimension AD as 1.5 and DC as 4 cm. We complete this figure. That is, we draw the same thing on the opposite side. Now, when we look at this new figure, it is a rectangle. And we know that a rectangle have two lines of symmetry.